We are finally now ready to go and look at the formula a squared plus b squared equals c squared. I know a lot of you have dealt with this in Study Island, and so here it is. What this talks about is the side measurements of a right triangle. In order for this formula to be effective, it must be in a right triangle. Its official name is the Pythagorean Theorem because it was made by Pythagoras a long time ago. So let's take a look at what we see in a right triangle. First of all, it has to have a right angle in it for it to count. Second of all is this: which side is always the longest? Can you tell in this picture which side has to be the longest, even without any measurements or hash or tick marks? The rule is the diagonal, the piece that is opposite of the right angle, is always the longest. This is important because it plays a huge role in where it fits. If you look at this triangle, the side opposite the right angle is the longest. The side opposite the right angle is the longest. The side opposite is the longest. Always and forever will be. Because this is the longest side, it has a special name. It is called the hypotenuse. Hypotenuse, 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 hypotenuse. That's the word for the longest side in the right triangle, opposite the 90. The other two sides really are interchangeable. They simply are called legs. They are interchangeable. They're not as important as the hypotenuse is. Alright, with this in mind, how do these three sides relate to each other? They are as follows. We won't use the words hypotenuse or the word legs. We won't even use the variable h. Instead, we'll use a, b, and c. And these must be with specific pieces. The hypotenuse is the special piece that gets the letter c. And it's easy to know because that's the one by itself. The other two does not matter which is which. Notice they must join together in order to work out to be worth c. Typically the top, the side, the height is a. Typically the bottom is b. It doesn't technically matter. So if I clean this up a little bit, I get a, b, and c. This is the definition. You must understand that these are the letters. The rest is simply plugging it into my formula and solving. So let's take a look at 2. In this case, I have a right triangle. I know the side. Okay, the phone rang while I was videoing, so I kind of forget where I left off. Right angle, hypotenuse is the side opposite. We have to figure out what this is. I'm going to use the formula, but before I do, what's one thing you can tell me about the answer without doing any calculations or math work? Just by definition, what do you know is true about this side? Hopefully you're saying this side has to be the longest. So give me a possible answer that it could be. Well, let me ask this. Give me something it can't be. The answer there is it can't be less than 4. It can't be equal to 4. It can't be equal to 3, and it can't be less than 3. It must be bigger than 4. It could be 4.1, but it must be bigger than 4. It cannot be equal to either of these sides. So I'm going to take my formula. I have to fill in my letters. Again, the hypotenuse automatically is c. These two, it does not matter which is which. Pick one. A, b, it does not matter. So I take my formula. A squared, 3 squared, plus 4 squared equals c squared. Can I do any combining right now? The answer is yes. I can do order of operations. 3 squared is 9, plus 4 squared is 16 equals c squared. Can I do any more combining? The answer is yes. 9 plus 16 is 25. I need to figure out what c is worth. I am not done. Why not? Because there is an exponent of 2. How do I remove an exponent of 2? The square root symbol removes it. You must put it on one side. In algebra, if it goes on one side, it must happen to the other. The square root gets rid of the exponent of 2. C equals. What is the square root of 25? The answer is 5. Double check your answer. Is this bigger than these? Yes, it is bigger than 4. Yes, it is bigger than 3. So my answer is 5. 3, 4, 5. By the way, this is a common right triangle. People will say a 3, 4, 5 right triangle. This is what they're talking about. 3, 4, 5 right triangle. Same idea, right triangle. Now I have to solve for a leg, a side. The hypotenuse has to be the longest piece. So tell me something you know about this. A true statement. This has to be smaller than the longest side. This must be lower than 12. Does it have to be bigger than 9? No. These can be interchangeable. They have no bearing on each other. But this must be less than 12. So let's fill in letters. This has to be C. I don't care what this is. I'll pick B and I'll pick A. A squared, because I don't know A, plus B squared, which is 9 squared equals 12 squared. Can I simplify anything? Combine? Yes, I can. I can do all my exponents. A squared plus 81 equals 144. I need to get the A all by itself. How do I get rid of anything else on this side? I can get rid of an 81 by adding the opposite. Negative 81 here, negative 81 here. Cross off, A squared equals 144 minus 81. Let me get my handy dandy calculator because I think I'm going to get a decimal later anyway. 144 minus 81 equals, or plus a negative, same thing. I get 63. The reason I did this example is because sometimes you don't get a whole number answer. Again, how do I get rid of a square? I must square root. I must square root. The square root removes the square. A equals. I'm going to round it. We're not going to go to the nearest whole number. We're going to go to the nearest tenth. So you get one place after it. 63, I need the square root of 63. Square root of 63 is 7.93. All right, which rounds to 7.9. Wavy equal signs to show that you rounded. Come back over. This now is 7.9. Check. Is it smaller than the hypotenuse? Yes, it is. Is it smaller than this? Yeah, it is. Is it bigger? No. Does it matter? No, it doesn't. These are interchangeable. So my answer here is 7.9, 9, and 12. Approximately 7.9. This is the formula. It can handle any of them. If I would have used B as the variable, it would have solved the same way. A squared plus B squared equals C squared.